Hi, everyone. Thank you for coming to my talk, and thanks, Nalcon, for inviting me. So before I begin, I would like to ask if anybody is familiar with Ruckus devices. Just raise your hand if you've seen them, use them, hack them, whatever. All right, cool. So this is how I met Ruckus. I saw them on Black Hat USA 2019. And I noticed that Ruckus provides the conference Wi-Fi. And actually, I also noticed that Ruckus access points are here in this conference as well. You can see it at the floor above. There are, I think, one just like the one I'm using here. All right. But when I got back home from USA, I was wondering how many vulnerabilities were discovered on Ruckus equipment. So I did a quick search on cvdetails.com, and I saw that Ruckus had 11 CVEs. 5 of them were critical, and the critical vulnerabilities were post-authenticated command injections. So basically no pre-auth RCE were published on Ruckus devices, only post-auth. So that either mean that they're super secure, or I'll let you answer this question yourself. So first, I would like to introduce myself. So my name is Gal Zror. I'm from Tel Aviv, Israel. I'm a research team leader at Aleph Research by HCL AppScan. And I've been doing reversing for around 10 years. I focus mainly on offensive embedded devices research. And this will also be a great opportunity to mention that we have open positions here in India. So if anybody is interested, feel free to contact me. Right, but in this talk, I will be using Ruckus 1 R510 Unleashed. So Ruckus has an unleashed version for every access point they provide. Unleash are access points that don't rely on Wi-Fi controllers. But the thing is that all the access points share the same vulnerable code base. And I also noticed that some vulnerabilities works on Zone Director product line, which is their Wi-Fi controller. Right, so the vulnerabilities I will show affects this firmware version and prior. Firmware analysis was pretty straightforward, no compression, no encryption, and on the R510, you can even get the kernel build config for some really odd reason. And what's really cool about this research is that I did this entire research with device emulation. Only when I actually discovered vulnerabilities, I bought an actual device. Okay, so I would like to introduce you to my emulation environment. I'm using a simple yet very useful emulation Dockers. On my Docker Hub, I got pre-built QEMU systems for different architectures, such as ARM v7, ARM v6, MIPS, and MIPSL. These Dockers really helps me emulating and setting up different router setups. And for this research, I used a Docker that wraps an ARM v7 QEMU system with a Debian kernel. Right, but enough about setup. Let's start with some exploits. So this is my first RCE attack. I will be fetching admin credentials without authentication, then pop a BusyBox shell with a jailbreak through SSH. And let's do a live demos, because live demos are fun. So this is a good time to pray for the demo gods and hope that everything will work smoothly. Okay, so I got my terminal here. Let me just see that my router answers. Awesome. And okay, so I'm gonna fetch a file from the router, from the directory user, WPS tool cache /var/run/rpmkey.rev. Okay, so I got the number 10. Now I'm going to fetch the same file only with 10 at the end, and then just pipe it through strings. And I'm going to grab something called all powerful login. Yeah, and as you can see, those are the device credentials, just like that. So next, after I got the router's credentials, I would like to log in. So I'm using the credentials I just fetched. And now I got this CLI. I'm going to use debug function, script, and then run the BNSH. And as you can see, I got myself a BusyBox shell. I am the admin user, and the admin user is part of the root group. So yeah, that's a shell. Thank you very much. So let's understand what we just saw here. So I started this research by examining the web server configuration. Ruckus uses embed this as its web interface server. And the configuration file looks just like that. We can see that it uses /web as its web root directory. And we also see that it uses EGS handler for .egs and .jsp extension. EGS is embedded JavaScript backend that the server uses. But the most important thing is what we don't see here. So we don't see any file fetching restrictions. That means I can fetch any file from /web directory regardless of its file extension or type. In other words, no access control whatsoever. Right, so now that I know I can fetch any file, I would like to look for some interesting file to fetch. There are 67 files that are not a standard web page, and 8 of them are symbolic links. One in particular is this one, which is a symbolic link to /tmp dir. That means every file I will fetch from /user/wps_tools_cache dir will actually fetch files from /tmp. All right. So since I was emulating the router firmware in QEMU system mode, I could run the system init scripts, and I noticed some files were written to /tmp on system startup. One of the files was this rpm.log. This log shows that every day the router writes a backup file called rpm key with a different reversion number. That file looked like a really good file to fetch, but the problem was that it was written to /var/run. I can only read /temp. Well, it wasn't really a problem since /var is also symbolically linked to /tmp. Yay for me. Yeah, I heard that. Now let's see how I was able to fetch the RPM key file. So /user/wps tool cache is symbolically linked to /tmp. /var/run is symbolically linked to /tmp/run/var. Now I was needed to get the RPM reversion number. Here in this example, it's 11. So there's a file called rpmkey.rev, and it just stores this number. So I first needed to send a request to get the number, and then I could get the right RPM key file. And after I fetched this RPM key file, I noticed it contains some binary data. So I just pipe it into strings, and as you can see, that's the device admin credentials in plain fucking text, right? It just doesn't get any better than this. Yeah, I see all the head nodding, and I just, yeah. Okay, so great. So now to finish my RCE, I wanted a BusyBox shell. So SSH can be enabled from the web interface. But here's the thing. Ruckus are using their own CLI. So at first, I tried to run BusyBox with a hidden command called !v54 ! And as you can see here, it's supposed to exit the CLI and enter the OS shell. But the problem was that it needed the device serial number for that command, and I don't got it. So I decided to use a different approach. Eventually, I used the CLI debug script mode that only supposed to run stored shell script like those. However, the exec command was vulnerable to path traversal, so I just used it to run bnsage, and I got myself a busybox shell as root. Yay for me. All right, so after this beginner's level CTF vulnerability, it got me thinking. There are probably more vulnerabilities to discover here, and I was really wonder in how many ways I can execute code on those devices. So yeah, that leads me to my second RCE attack. Here I exploited a Stack Overflow vulnerability with authentication, with unauthenticated request to an Ajax function. Yeah, but before that, I would like to talk about a Gal script that I wrote that really helped me with the reversing process. So Ruckus has left all their log strings in the binary. As you can see here, there are info, error, warn, and debug logs. Here we can see a Gal decompiled code for a function, and this function uses debug log print. What's even better is that Ruckus also prints the function name for every log print. So I just wrote a script that searched for these log prints and renamed unnamed functions with a function from the log prints. In this case, I renamed this function from unknown function to get ZDDN. Oh yeah, so here we can see that for a binary called EMFD, I was able to reduce its undefined function from 1500 to less than 900. And that made the reversing process way shorter. So based on that script, our team member Vera Mentz and I wrote a generic Gal script. This script searched for patterns in Gal decompiled code and renamed function with those matches. This script is available on Aleph GitHub account, so feel free to use it. It's really useful for many reversing projects. All right, but let's get back to the second attack. Now I would like to present three important binaries in the web interface. So the first one is /bin/webs. This is the actual embed this web server. It handles HTTP requests and execute handlers according to its configuration, like we saw on the first attack. It then sends commands through a Unix domain socket to EMFD. /bin/EMFD is an executable that contains the web interface logic. It maps function from web pages to its own functions, and it then implements interface commands such as backup, network configuration, retrieve system information, and many more. And the last one is libemf. This library is used by EMFD for some authentication, some sanitation, and code execution. And now in a diagram. So webs listen to HTTP/HTTPS. If it receives a JSA page, it uses EGS handler to pass a function to EMFD. EMFD then checks if the function name is mapped, and if so, it calls a function pointer. Eventually, EMFD runs some kind of shell script, for example, ifconfig, IP tables, route, etc. And I will get back to this later, but look at this area carefully, because this is where everything messes up. Right, so for example, when sending an HTTP request to /admin/_update guest image name.jsp, webs invoke the EGS handler. This handler uses a function called delegate, which sends a command to EMF through a domain Unix socket. EMFD then maps every string it received to a function pointer and runs it. Here we can see that EGS handler sends upload verify string to EMFD, and EMFD then maps this string to a function also called upload verify. Okay, so next let's talk about authentication mechanism. So there are 4 permission level which are admin, user, FM, and guest. Here we see that for each user has a page with a delegate function call. For example, fm login.jsp uses authfm function, and user underscore login.jsp uses authUser, and so on and so forth. Once a user is authenticated, his session is stored in for a specific period of time. Each JSP page should check if the session is valid before calling other delegate functions. Here we see that underscore underscore cmdstat.jsp checks for session first and only then calls the function ajax cmdstat. So I used grep and I got 67 pages that do not perform any kind of session check. I then listed all the different functions that I can reach without authentication. And one very interesting function was this one, which is Ajax restricted cmdstat. Here we can see that it does not perform session check and can be reached by sending a request to /tools/_rcmdstat.jsp. All right, but let's move on to a live demo that implements Stack Overflow. So I'll just need to make sure. Okay. Hopefully the demo gods are with me. All right. So this is my terminal. And again, so now I'm just gonna check that I don't got anything listening to 1, 2, 3, 4, 5, which is the backdoor I'm gonna create in a minute. And now I would like to show you guys the Stack Overflow payload. So this is an Ajax request, and I'm using the server attribute, and I'm passing this overflow, and I'm executing telnet D to port 1, 2, 3, 4, 5. Okay, so let's make it happen. And I'm just gonna post this Stack Overflow payload to my router, to tools_rcmdstat.jsp. And this is the moment of truth where everything works, hopefully. In a minute. It's okay, got it. So message okay, it's a great indication that everything is working. And now I can just log in into this 1, 2, 3, 4, 5 port using telnet. And as you see, I got myself a busybox shell, and I am the admin again, which is, of course, part of the root group. And this is it. Thank you very much. Yes, one more demo to go. Okay, the last one is the most complicated one, but yeah, we'll make it through. Well, okay, so to understand how I was able to exploit this Stack Overflow, I would like to explain how Ajax request works. So I was able to run both Embeddis web server and EMFD on the QEMU system emulation. And that way I was able to inspect a standard Ajax request like this one. So here I call the underscore cmdstat.jsp page, which is mapped into EMFD to a function called Ajax cmdstat. Ajax cmdstat receives an action attribute from the request. Since the action is do cmd, it uses an adapter called adapter do command. Adapter do command calls to a do command function. Do command function is basically a large switch case function that executes different logics based on what it gets on the attribute. In this example, it gets get connect status, which calls a function called cmd get internet status. Now let's look on a page that do not perform this session check. Yeah, as you can see, no cookie. EMFD maps underscore rcmdstat.jsp to a function called Ajax restricted cmdstat. This is where the R come from. This function also called Ajax cmdstat, but with a very limited set of commands. This specific request passes cmd zapd to do command, and it runs an executable called zap. This is how zap command runs in the shell. We see that we can control its server and client argument by passing attributes server and client. And the thing is, the server and the clients are not sanitized good enough. So I could just pass unintended argument to zap. In this example, I'm passing -d/tmp/b, comma, crush me please. Okay, so I was able to find zap sources online, and Ruckus described it as designed to be a robust network performance test tool. And when I examined the code, I noticed there's a stack buffer overflow in -d argument. Yeah. Here's the code that parses the -d argument. Let's see what it does. So first, it replaces all commas character with spaces. Then it copies every segment to a temp buffer. And since it expects a number, it uses a very small buffer, 10 in this case. And well, Ruckus tried to be secure here by using str_n_copy, but they use the entire string length for n. So it doesn't really protect anything, and I was able to smash the stack anyway. And for exploitation, so the R510 uses both NX and ASLR. To overcome NX, I decided to use rope gadget. I used 2gadget to run a system with a pointer to my payload. And in this case, I'm using telnet-d to run bnsage as a login page on port 12345. As for ASLR, since zap is forked from EMFD, I can just use a brute force approach and overcome its 9 bits of randomness. All right, so now I would like to look at a request that runs zap command again. If I can control the server and the client attributes, why can't I just use it for command injection? Right? To understand this, I need to understand how zap command is being executed. Here we see that do command uses exec sys command implementation to run zap. So exec sys cmd implementation is a function in libmf. This function first calls to find sys wrapper function, and then it uses vfork_n exec_v to execute a shell command. Now let's look on find sys wrapper decompiled code. We can see it looks for /bin/sys_wrapper.sh. If this script is available, it updates a global variable that I named sysWrapperPath. Now, exit sys cmd implementation execute /bin/syswrapper, and in our case, it runs zap command with the arguments from the Ajax request, such as our server and client. Okay, so as you can see, syswrapper is a very big shell script. It handles many commands, but what's really interested me was the zap execution command. Here we see that /bin/zap is being executed with opt variable. This variable receives both server and client values from our request. However, ops gets its value with a quotation mark, and that stops me from injecting other commands. Yeah, well, I was really hoping for this command injection, and this made my life sucks for a while. But what kept me really entertained and motivated was the fact that Ruckus had the weirdest CLI in their firmware. So before I continue with my next attack, I would like to show you another Ruckus CLI. So this is the CLI I had to escape when I used SSH on my first attack. And this is an entire different CLI that's also being used by the device. I noticed it can be reached after system resets. So this CLI also got the hidden command exclamation mark, v54 exclamation mark, that also supposed to escape to a BusyBox shell, but it also needed a device serial number, and I don't got this number. So, however, this v54, this one uses content from a file called access in writable etc system. The content of this access file was written by another hidden command called Ruckus. Well, I discovered that Ruckus command can write a command injection payload to v54, and then it can be triggered by calling the v54 command. And then, and that way I was able to escape to a BusyBox shell. But that's not interesting. What's really interesting is the weird stuff. So when I called Ruckus command to save my payload, this is the output I got. And this one, and this one. Yeah, wuff wuff, bow bow, and rough. Right? Yeah, so the CLI actually barks at you. Yeah, and now when I call the v54 to execute my command injection to escape shell, well, it asked me what the chow. As in chow chow dogs? No, seriously, what the actual fuck? Yeah, but at the end of all of this, I was able to run a BusyBox shell, so I didn't really care about those weird Easter eggs, but still it was pretty entertaining, worth mentioning. Well, I still wanted to receive a pre-auth RCE by command injection. I just knew that EMFD gotta be vulnerable. It took me some time, but eventually I was able to make this happen. So this is my last attack where I found command injection vulnerability, and I was able to reach it without authentication by writing my own web page. Okay, so as I mentioned before, EMFD executes code in a really messy way. EMFD sometimes uses libemf, other times calls the shell script syswrapper.sh that we saw, and sometimes just run a command itself with libc. These are all the different functions that EMFD uses to execute shellcode. As we can see here, there are 107 libc system function call. So I had to find a page that uses this system function without sanitation. And actually, I was able to find 4 functions that call system and were vulnerable to command injection. Today I will be showing the injection on the last one, which is cmd import avp port. All right, so to reach the vulnerable function, I needed to send an AJAX request to /admin/_cmdstat.jsp. And my request should look something like this. I'm passing a command with cmd equals import avp port. This uses do command to call cmd import avp port function. This function uses libc system function unsafely. Here we can see that the function, we see the function decompiled code. So all I had to do is to pass a command injection in the upload file attribute. And as you can see, it just executed without sanitation. All right, so was it that simple? Well, no. I still needed to be authenticated to reach this function. As you can see here, I'm using a valid cookie. Well, the problem was that _cmdstat.jsp page checks for session, and only then it calls the vulnerable AJAX cmdstat function. Also, so I needed basically a different approach for this problem. And what if I could write a new page that only calls AJAX cmdstat and do not use the session check call at all? it might actually work. It did work. For this, I decided to use the zap executable again. Zap has a lot of different arguments, and we already know that we can pass unintended arguments without any authentication. So one of them is to set a path for Zap's log. However, writing a file is not enough. I need to control its content as well. Well, for this, I used these tag, sab, and node arguments. They get a string and just write it in the log file for some extra information. So here's the log file writing code. It gets the file path directly from -l argument. And I can control the log content by passing the arguments node, tag, and sub. Well, that's great, but unfortunately there are more problems to solve here. So I want to write a page, and it has to be on the /web directory. The problem was that /web is a part of the squashfs file system, which is a read-only file system. Luckily, /web/uploaded directory is symbolically linked to /writable/etc/airspider. And this directory is on a writable file system. Yay for me. Okay, so now that I knew I can write a file with my content to a writable web directory, the only problem left to solve was that Zap executable needed to connect to something called TX station. Otherwise, it will not write any log file. Well, since I got Zap sources, I was able to compile this TX station, and now I can set Zap to connect to a TX station on my computer. Awesome. So this was the request I needed to send, and it executed this zap command. Notice that I'm using two arguments, -s and -t tag, to write my delegate call. Finally, Zap has wrote a log file to /web/uploaded/index.jsp. Although this page was pretty much full of junk, that did not bother me because what interested me was the delegate call to the vulnerable function. Okay, so I could now chain those two vulnerabilities together. First, I write a page to /web/uploaded/index.jsp. Now I can send my command injection payload to the page I just wrote. All right, this is the time for the most complicated demo, so I'll drink water before that. Okay. So for that, we'll need two terminals. The first one, wait, let me just get out of this one. Awesome. Okay, so on the first one, I'm gonna run the TX station, which here it's called zapd. And I'm gonna listen to port 4444 for a reverse shell. Now, okay. Now I would like to show you guys the page create payload. So I'm using the server attribute again, and now I'm writing a page called index.jsp with a delegate call, right, to Ajax CMD state. So let's just write this page. I'm going to post it, page create to the router, tools, _rcmdstat.jsp, and hopefully I'll get myself a new page in any minute. Okay, awesome. Now I would like to show you the command injection payload. So I'm using the attribute uploaded file, and I'm gonna run netcat to connect to my host on port 4444, to my computer on port 4444. All right, so let's send the command injection payload to the router. Uploaded. This is the page I just wrote. Uploaded index.jsp. Okay, and now I can switch to my other terminal, and hopefully you can see that I am the root user. And of course, the root user is part of the root group in PassWD. Right, this is it. Okay. So, in conclusion, I demonstrated today 3 pre-auth RCEs. The first one was credential leakage with CLI jailbreak. The second one was Stack Overflow without authentication. And the last one was command injection with authentication bypass. I also shared my Docker setup and introduced a very useful Jira script that helped me with my research and I think can help others. Well, Ruckus network was informed about these vulnerabilities. I requested 10 CVEs for this research and they confirmed these CVEs. And yeah, if there are any Ruckus users here, you should stop what you're doing and check that you run the latest firmware. If not, you may be a victim to a very serious abuse. So again, check that the firmware is updated, please. Okay, and since I published my research, I was able to fingerprint some interesting users with Shodan.io. 2 of them were Brazil's and Ireland National Research and Educational Networks. These are very big networks that usually connect to high-speed backbones. Well, these networks did not update their firmware, and they were exploitable from the internet. And, well, the funny part is that Brazil's network is actually posting vulnerability alerts on Twitter. But, yeah, they did not know about their own vulnerabilities. Well, anyway, I informed all the networks I was able to find on the internet, and hopefully all of them updated their devices. And well, so this research was a lot of fun, and it involved all sorts of different vulnerabilities. Well, it was also an excellent opportunity to check my Docker emulation environment, which proved itself very useful. There's a blog post if anyone wants to get into further details. So check out the post. It's on alefsecurity.com. And while you're there, check our other amazing research done by the team. And yeah, so I would also like to mention that I conducted a follow-up research on Ruckus and found more vulnerabilities and different way to gain pre-auth RCEs. Yeah, so at this moment, unfortunately, we're still in a disclosure process, so I can't get into details, but I will definitely share my findings in the near future. And yeah, so this is it. Thank you guys very much for listening. Right.
Thank you, Gal, for an amazing session. Our next session is by Alexei. Alexei is a senior specialist in the threat analysis group. He will be delivering a session on malware number 41, a new sophisticated loader by APT group TA505. Sir, stage is yours. If anyone want to ask some question to Gal sir, you can ask. Anyone? Please. Sir.
The TX station bit, I did not get that part, and if it's there on the blog, then it's fine. I'll read up more on it. In case you are getting delayed.
Yeah, if you can repeat the question.
That part about the TX station bit, that part, the TX station that needed to be set.
So like the authentication session?
Yeah.
So basically, each page checks if the session is valid before continuing with other functionality. And the thing is that Ruckus did not perform this session check for some pages. So this was the attack vector, if I'm like the attack surface, because I needed to find pages that did not perform this session check, which is a delegate call, which is like a mechanism in the EMFD. So I just needed to map all of those, and those are the files that I needed to attack in order to get like privileged escalation or do stuff like posted without authentication, pre-auth. Right? Any other questions? All right, thank you guys.
So have you ever encountered a situation where you are able to discover the remote code execution and vendor is not responding to you?
Wait, I can barely hear. Yeah.
Have you ever encountered a situation where you discovered a critical bug like RC again, pre-auth RC, and vendor is not responding to you?
Are you talking about like the third RC or?
No, any RC in any other product maybe where vendor is not responding to you after reporting to vendor?
Okay, I told Ruckus about everything. We started disclosure around September. So now all the things I showed supposed to be fixed in the latest firmware.
So do you have to take a written permission for that? Like I'm presenting my research with Ruckus?
I'm not sure I understand. Can you revisit?
Okay, we'll take it offline, no problem.
Okay, sure. Thanks.